But yeah, if anything stops being easy to see, easy to hear, whatever, just holler out so that we can fix it. All right. So we're looking at the last two functions before we do a little bit more with modeling, which is pretty cool. So we know that tangent repeats every other quadrant because tangent is positive in quadrant 1 and positive in quadrant 3. It's negative in quadrant 2, negative in quadrant 4. So its period is just pi. So the period of the tangent and the cotangent is just pi. Every time that, let's see, tangent is sine divided by cosine. So every time the cosine equals 0, tangent is undefined. So that means all odd multiples of pi over 2. So for all z, for all integers n, if we have 2n plus 1 times pi over 2, then the tangent will not be defined for that. We also have a couple of nice values for tangent. What is the tangent of pi over 4?
One.
Good. That's really important because we know that when the sine is 0, in other words, where we start off at 0 radians, we have sine divided by cosine. Sine of 0 is 0 divided by a non-zero is 0. So at the origin, we get a 0, but we get a really nice value right here in the middle between the x-intercept and the first vertical asymptote. And that's because of the tangent of pi over 4 is 1. Also, we know that the tangent of 3 pi over 4 is what is the tangent of 3 pi over 4?
Undefined.
It's defined.
Oh, wait.
It's midway along in the second quadrant.
Oh, 3 pi over 4.
Yes.
Yeah, that would be negative 1. Sorry.
That's all right. Okay. So that means that if we go back one, midway between the origin and the previous vertical asymptote, we'll have another 1. And those two 1s really help graphing the tangent. So let's see. Oh, thanks, Ben. Okay. So we know that at 0, we get 0. At negative pi over 4, we get -1. At pi over 4, we get 1. So we're sort of expanding out. As the cosine gets smaller and smaller, what happens when you divide by a number that is less than 1? Like if you've got 5 and you divide it by 0.9 and then 5 divided by 0.8 and then 5 divided by 0.7.
Gets bigger.
That's right. As the number in the denominator gets smaller, the entire number becomes bigger. And that's exactly what happens to the tangent. So as we get closer and closer to pi over 2, the cosine is getting smaller and smaller. That's blowing up the tangent. And that's why it goes to positive infinity when it gets close to pi over 2, and it goes to negative infinity when it gets close to negative pi over 2. And it repeats that pattern forever and ever. All right. So tangent is kind of cool because if we want to graph A tan bx minus c, A is going to give us these two values. We'll have negative A and A. So we can ignore A for a minute. Let's just look at this. We've got bx minus c. And what we're going to do is sandwich this between its two closest asymptotes, negative pi over 2 and positive pi over 2. And we want to find any x that has that property. Well, we're going to add c and divide by b, right? And that will give us two new adjacent vertical asymptotes. So let's see. What if we had, I will do an example that's in here. What if we have y is equal to 2 tangent 3x? So in this case, what is A, what is B, and what is C?
A would be 2.
Beautiful. Hi, Ben.
B would be
Hello.
3.
And C?
C and D are
0.
0.
Good. Okay, awesome. So we know that A is going to give us these nice values at negative pi over 4, or midway between 0, 0 and the right vertical asymptote will have a value of A, something comma A. And then midway between 0, 0 and the negative the closest negative vertical asymptote will have negative a. So now we can ignore the a's and just look at bx minus c. So this time there's no c, it's just 3x. And we have this. So I want us to get really comfortable multiplying instead of thinking of it as division. So we want to get rid of the 3 next to the x. We're going to multiply by 1/3. And that gives us negative pi over 6 is less than x is less than pi over 6. So these are two adjacent vertical asymptotes. The negative pi over 6, positive pi over 6. We don't have any shift, so I know that the center of everything is going to be 0, 0. Now I just need to figure out what is the midpoint between 0 and pi over 6. So to find the midpoint, add and divide by 2. So there's not much to add because we're going to take 0 and pi over 6. We're dividing by 2. That's the same as multiplying by 1/2. 0 isn't there. So now I see that I'm just going to get pi over 12. So this midpoint is pi over 12, and that will give me the value of a. We said a was 2. So there's my point. And let's pretend that we don't know that we could just go negative pi over 12. We've got 0 plus negative pi over 6 times 1/2. And that's negative pi over 6 times 1/2, which is negative pi over 12. That gives us the x coordinate, or the negative a y value. So here a was 2, so we've got pi over 12 comma 2 and negative pi over 12 comma negative 2. And that's really all we need, because we already talked about what happens when tangent gets close to its asymptote. It's going to blow up. There we go.
So
yeah,
I would like to ask a question. So you're finding your midpoint. Midpoint is which one? The and one
so
where
there are two things we're finding the midpoint. We're finding the midpoint between negative pi over 6 and pi over 6 to get the intercept. Right. And then we're finding the midpoints between that intercept and each of the asymptotes.
So what are we adding here? We're adding, because there's a 0 plus pi over 6.
Yeah, we're adding the x coordinates. the x coefficients.
Oh,
So
I
this
see.
is, yeah. So this center point is 0, 0. This point at the asymptote is pi over 6 comma nothing because it doesn't exist there. And then we've got negative pi over 6. So we're just looking at the x values, and we're trying to find an x value that is midway between 0 and pi over 6.
Oh, I see it now. Okay, thank you.
Okay, good question. Oh, that's not what we're doing right now. And you can see the notes have a prettier version of this, but we do go through the origin, and then at pi over 12 we have 2, and at negative pi over 12 we have negative 2. Well, that was too easy. Let's do another one. Let's graph y is equal to 1/4 tangent 3x plus pi over 4. Okay. All right. So A, B, and C.
Sorry, I was writing that down. A is 1/4. B
Yes,
is 3. And C is pi over 4.
almost. There's
Negative pi
something
over
in front
4.
of the pi over. Yeah,
Oh, negative.
because there's a plus sign. So I have to do 3x minus negative pi over 4. So good. So we know that this A is going to give us the y value when we're between the intercept and the vertical asymptote. So we can ignore it for now. And let's just look at 3x plus pi over 4. We're going to set this between negative pi over 2 and pi over 2. And how can I solve for x? What should I do first?
Subtract pi over 4.
Good. And inequalities are fun because there's now more than two sides. So we're going to subtract pi over 4 from everywhere. That's going to leave us with 3x in the middle, negative pi over 2 minus pi over 4. Can I just add them the way they are, or do I need to do something?
You do something.
Tell me what.
You can multiply negative pi over 2 by 2.
Good.
Yeah.
And that gives us negative 2 pi over 4 minus pi over 4.
Negative pi over 4.
Almost.
Negative 3 pi over 4.
Good. Very good. So now we've got negative 3 pi over 4. And at the other extreme, we had positive pi over 2 minus pi over 4, and we're multiplying again by 2 over 2. So now we've got
2 pi over 4 minus pi over 4, which would just be pi over 4.
good. All right. How can I get x by itself in the middle? What?
Divide by 3.
What? How can I think of it as in multiplication terms?
Multiply by 1/3.
1/3.
Good, good. And you're absolutely right, Sir Ralph. Okay, so let's see. On the very left, I've got a negative 3 pi and a 3 in the denominator. What can I do with those 3s?
Cancel them out.
Good. And we're left with negative pi over 4. On the right, nothing to divide out. It looks like we're just going to have pi over 12. Is that right?
Yep.
Okay, good. So that means that our two vertical asymptotes closest to 0, 0 are going to be at x equals pi over 12 and x equals negative pi over 4. Let's see. 1 pi over 12, pi over 12, 2 of them, that's pi over 6. Pi over 12, 3 of them, 3 pi over 12, that's pi over 4. And then that's 3, 4 pi over 12.
Miss, we can't see the graph. There we go.
Thank you so much. I'm confusing myself. So I've got 2 pi over 12, 3 pi over 12, 4 pi over 12. This is pi over 6. Divide by 3, that's pi over 4. And then we get pi over 3. And then 5 pi over 12. We don't need to go any farther. Let's remember that we've got our two vertical asymptotes. The one on the right is pi over 12, and the one on the left is negative pi over 4. And that's why I stopped. Where did I even have it? Yeah, I think so. The graph just went to the floor, so I'm going to sketch it again. So pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, and pi over 2. In the other direction, I'm just going to go as far as the negative pi over 4. So negative pi over 12, negative pi over 6, negative pi over 4. And
I
we
would
said
like to
A
ask,
was, yes.
I'm sorry. How far do you know, like, to go from the x-axis?
Okay, so we know that we want to go in the positive direction as far as pi over 12 and in the negative direction as far as negative pi over 4. But I like to balance it. So both of them go at least to pi over 4. Then we've got our value of A. And we're just about ready to go. This one is fun because we've got our vertical asymptote. No longer are they symmetric with respect to the origin. So to find the midpoint, between the x values, negative pi over 4 and pi over 12, we're going to add and divide by 2, or multiply by 1/2. So I've got negative pi over 4 plus pi over 12 times 1/2. What do I need to do to combine the two fractions?
Common denominator.
Good. And it looks like 3.
Yes, multiply by 3.
Does that show up? Not very well.
It shows up decently well.
Oh,
It's
okay,
okay.
groovy. So that gives us negative 3 pi over 12 plus pi over 12. And we're going to multiply the result by 1/2. What is negative 3 plus 1?
-2.
Good. So negative 2 pi over 12 times 1/2. Can I just divide out some 2's here?
Yes.
Good. So the end result here is negative pi over 12. This is going to give us our intercept. So the x-intercept is negative pi over 12, 0. When we had symmetric asymptotes, the intercept was always at the origin. But here we're not symmetric, and our intercept in the middle is not at the origin. So we are at negative pi over 12, groovy. And we kind of cheated because we counted off by pi over 12s. So I can see where the midpoints of these midpoints are going to be. But I still want to do the math to make sure that I can do it. So here I'm going to add negative pi over 4 plus negative pi over 6 times 1/2. What is the LCD for 4 and 6?
2.
Yeah, 12. Good. So we have negative 3 pi over 12 minus 2 pi over 12. And that'll give us
-5 pi over 12.
great. And that'll give us negative 5 pi over 24. Great. Oh, okay. Duh. Okay, this is a pi over 12, not a pi over 6. I was thinking, this doesn't make sense. We should be getting negative pi over 6. Okay, so that gives us negative 3 pi over 12 minus another pi over 12 times 1/2. And now we get negative 4 pi over 12 times 1/2. And again, let's just reduce before we multiply. Divide by 2, divide by 2. We get negative 2 pi over 12, which does reduce to negative pi over 6. This one in the negative direction is going to be matched with negative a. So negative pi over 6, comma, negative 1/4. On the other side, we've got negative pi over 12 plus pi over 12. That's kind of nice. Negative pi over 12 plus pi over 12 times 1/2. And what are we going to have in the parentheses?
0 comma a.
Yes, very good. Oh, thanks.
No problem.
And there we go. And this one is more beautiful, but we have all the same information. I numbered the try thises between the two assignments that we're going to cover, but I wasn't thinking, I numbered these after the others. So we're going to start with a try this 3. So as always, I'm going to mute myself, but I'll be here and I want to hear y'all talking.
Good morning, guys.
Good morning. I'll just be a second. I'm gonna go get my pen.
Okay. By the way, it's also recording.
Thank you. Thank you. Okay. So for cotangent, we know that it has a period of pi. It has vertical asymptotes at every multiple of pi. And to set it up in a way similar to the way we set up the tangent, we would put 0 on one extreme, pi on the other, and bx minus c in the middle. And then we'll just solve for x, and that'll give us 2 adjacent, or right in a row, vertical asymptotes. And then we'll go from there. So let's look at example 3. We have y is equal to 3 cotangent of 1/2 x minus pi over 4. What are a, b, and c?
A is 3. B is 1/2. and then c would be pi over 4.
Excellent. We're going to use the a to get our two values on the in between the 0 and the asymptote. So for right now, we're just going to look at 1/2 x minus pi over 4. And we're sandwiching that between 0 on the left and pi on the right. And what should we do first if we're trying to solve for x?
Add pi over 4.
Good. So we have 1/2 x in the middle. 0 plus pi over 4 is just pi over 4. How can I combine pi with pi over 4?
Multiply pi by 4 over 4.
Good. And that gives us 4 pi over 4 plus pi over 4, or 5 pi over 4. I'm going to think in terms of multiplying. What can I multiply all three sides by so that I get x alone in the middle?
2.
Yes, good. So let's see. We have pi over 2 on the left and 5 pi over 2 on the right. Is that right?
Looks right.
Groovy? So now we've got pi over 2, 5 pi over 2. And I need to find the midpoint. So remind me how to find the midpoint if I know two x values.
You multiply them. Sorry, add them. You add them together.
Good.
And then you take the answer of that and multiply it by 1/2.
Very good. So that gives us 6 pi over 2 . What can we do with that 6 pi over 2?
Reduce it.
Good. To get
3 pi.
beautiful. And 3 pi times 1/2 is just 3 pi over 2. So that's nice because I can see if I counted by pi over 2s, I definitely would have 3 pi over 2 in the middle. The next thing I'm going to do is look for midpoints between pi over 2 and 3 pi over 2, and between 3 pi over 2 and 5 pi over 2. And I know, because I'm thinking in terms of halving things, that it's going to be something over 4. So I've got pi over 2 plus 3 pi over 2 times 1/2. That gives us 4 pi over 2 times 1/2. Oh, maybe not. No, it
It
has
would
to
just
be.
wouldn't it just be pi and then 2 pi?
Yes, it will be. Yes. Lovely. And so we should get also 2 pi for the second one. So let's see. We've got 3 pi over 2. And we're trying to find the midpoint between 3 pi over 2 and 5 pi over 2. So we get 8 pi over 2, which is
4 pi.
good. So that gives me 4 pi times 1/2, which is going to be
4 pi over 2.
good. Very good. We said that A was 3. So it goes the same way. How are we going to make the picture look different though? Let's see. So at pi, we've got, I'm in quadrant 1, so I'm up. This is the point pi comma 3. And in quadrant 2, that's where we've got the negative. So 2 pi comma -3. And then I get the backward looking graph that we know and love as the cotangent.
So just to clarify,
Yeah.
since this is cotangent,
Yeah.
our first midpoint is going to be positive, but if it was tangent, it would be -3 instead of +3.
So, okay. You mean right here?
Yeah.
So yes, because it's cotangent, when I'm looking at this first, the space between the first vertical asymptote and the center, that's quadrant 1. And when we're looking at the space between the center and the second vertical asymptote, that's quadrant 2. And that tells me where the points need to be. In quadrant 1, we're positive, in quadrant 2, we're negative.
Okay, cool.
Yeah, because cotangent starts at 0, 0 and goes to pi. So we're starting out looking at the first 2 quadrants. Halfway, we're in quadrant 1. Then after halfway, we're in quadrant 2.
Okay, cool. Thank you.
You're welcome. Okay. Oh, I'm going to stop and start. So I'm just